Imagine looking at the horizon and experiencing a sunrise that covers half the sky. NASA has released images of an unheard-of phenomenon in which a star, dubbed Betelgeuse, just lost its top, ejecting a gigantic portion of its surface mass. This event is called a surface mass ejection. According to the space agency, the ejection was 400 billion times the mass of an ordinary solar flare from our sun. Scientists describe the event as watching stellar evolution in real time, with a star blasting off such huge chunks of its surface, altering its physical appearance. Betelgeuse and its importance. Most of what we know about red supergiants is being challenged by this event. Why did Betelgeuse eject such a massive amount of material? And how will that influence the universe? Let's investigate. Constellations are made up of many stars and are often arranged in accordance with myths and legends. Even today, they are used for navigation. One such star is Betelgeuse, one of the brightest and largest stars in our nighttime sky. It glows with a brilliant ruby-red color and is located in the upper right shoulder of the winter constellation Orion the Hunter. Astronomers have identified Betelgeuse as a seething monster with a 400-day-long heartbeat of regular pulsations. Its deep orange-red color makes it easy to recognize and serves as a great example for demonstrating that stars actually have different colors. Also known as Alpha Orionis, Betelgeuse is the second brightest star in the Orion constellation. It was named in honor of the blue supergiant Rigel, another bright star in Orion. Despite its brightness, Rigel is more visually dominant than Betelgeuse. However, Betelgeuse holds the Alpha Orionis designation due to its size and reddish hue. A star of many legends, Betelgeuse is one of the most famous stars in the night sky. It even served as the inspiration for both Betelgeuse, the movie, and the character Betelgeuse. It is the seventh brightest star visible from North America, Europe, and Canada, and the 10th brightest overall. Although Betelgeuse is relatively close to Earth, astronomers cannot pinpoint its exact distance. Estimates place it between 430 and 724 light-years away. It is the brightest red supergiant and the closest to Earth in our galaxy, which contains only around 200 red supergiants in total. Betelgeuse's immense size. Betelgeuse is massive. Its radius is approximately 764 times larger than the Sun's. If it replaced our Sun in the solar system, it would extend past the asteroid belt and possibly beyond Jupiter. This means Mercury, Venus, and Earth would be completely absorbed. To put it in perspective, Betelgeuse is 16,128 times larger than the Sun and has 26,000 times the Sun's luminosity. It is visible from 548 light-years away and has a surface temperature of around 3,600 Kelvin, making it slightly cooler than the Sun. Interestingly, 13.3% of Betelgeuse's radiant energy is visible light. If it emitted light at all wavelengths, it would outshine Sirius as the brightest star in the night sky. A dying giant, Betelgeuse is constantly losing mass, ejecting approximately one solar mass every 10,000 years. A nebula, about 250 times larger than Betelgeuse itself, surrounds it due to the uneven expulsion of material. This nebula is estimated to be 30 astronomical units in size, equivalent to 30 times Neptune's distance from the Sun. The Sun also ejects mass into space in the form of solar flares, but these are much smaller than the coronal mass ejections, CMEs, that Betelgeuse experiences. A CME occurs when a star's unstable outer atmosphere expels material. CMEs from our Sun can affect Earth, sometimes disrupting satellites and power infrastructures. If a CME is powerful enough, it can even pose a threat to astronauts in orbit. The 2019 Betelgeuse outburst. In 2019, Betelgeuse experienced an unprecedented surface mass ejection, SME. The expelled material cooled in space and formed a dense cloud of cosmic dust, temporarily dimming Betelgeuse's brightness. This event also disrupted Betelgeuse's usual pulsation pattern. NASA scientists describe the SME as 400 billion times more massive than a typical CME, causing the star to wobble like a dish of gelatin. According to Andrea Dupree, an astronomer at the Center for Astrophysics, the star's convection cells may now be in disarray. Observations suggest that Betelgeuse's photosphere is struggling to reconstruct itself after the event. Observing the death of a star. Betelgeuse, like all red supergiants, is nearing the end of its life. Studying it provides valuable insights into the life cycle of stars. Most stars in the universe are powered by nuclear fusion, but when fusion stops, a star undergoes a series of changes before eventually dying. A star like Betelgeuse initially fuses hydrogen into helium, generating immense heat and light. As it ages and depletes its hydrogen, it begins fusing helium into carbon, then carbon into neon and eventually iron. Once iron fusion begins, it consumes energy instead of releasing it. With no outward pressure to counteract gravity, the star collapses and triggers a supernova explosion, one of the most powerful events in the universe. A supernova can release more energy than 10 billion suns in a matter of seconds. The changing colors of Betelgeuse. Throughout its life, a star's color changes depending on its temperature and stage of evolution. Younger stars tend to be blue and hot, while older stars like Betelgeuse appear red and cooler. Interestingly, historical records suggest that Betelgeuse may have looked different in the past. The Greek scientist Ptolemy described it as ruddy-colored in 168 AD, while ancient Chinese astronomers recorded it as yellow. This could indicate that Betelgeuse was once a yellow supergiant before evolving into its current red supergiant phase. Giant astronomers might improve understanding of how red stars lose mass in their last days before exploding in a bright supernova. From Betelgeuse's explosion, as Dupree notes, we've never seen a huge eruption of mass on the surface before. We are left with a star, something going on that we don't completely comprehend. This is a brand new phenomenon that we can directly observe and use Hubble to resolve surface details. We are actually following stellar evolution in real time. However, it's unclear whether Betelgeuse's dimming signals an impending supernova explosion. NASA cautions that Betelgeuse might not have reached the end of its life, even if it is nearing the end. Cosmic time is long, and red supergiants die quickly by comparison. According to NASA, Betelgeuse will explode within the next 100,000 years. Betelgeuse has been the primary focus of intense study since the 1st century BC. More recently, a scientist named Saran Nance and her team sought to determine the potential timing of supernova explosions in red supergiants like Betelgeuse. Their goal was to understand how a star of such immense size would behave over time. Nance and her team ran multiple simulations using Betelgeuse as a model, and then compared their findings with field observations. Why did Betelgeuse unexpectedly dim, out of sync with its regular cycle, when it isn't likely to explode for another 100,000 years? In that year, Betelgeuse was forced out of its home in the Orion OB1 association, which includes the stars in Orion's belt. It has been observed moving through the interstellar medium at a speed of over 4 light-years per million years. By mid-February, Betelgeuse had lost approximately 3 times more brightness, dropping from magnitude 0.5 to magnitude 1.7. The significant dimming began in October 2019, and by February 17, 2020, Betelgeuse's brightness had been stable for almost 10 days. The star had started to brighten once more. However, 5 days later, the dimming incident effectively ended as Betelgeuse stopped fading completely. Since there were no significant changes in the infrared on February 24, 2020, it appeared that the recent visual fading was unrelated to an anticipated core collapse. Another study found that the dimming was most likely caused by a cloud of dust with large grains covering the star. The absence of significant absorption at shorter wavelengths supported this conclusion. However, the fading also appeared to be caused by large star spots. Further analysis showed a significant increase in Betelgeuse's brightness between May and August. Betelgeuse is so close to the Sun that it was almost impossible to observe from Earth before 2020, when Betelgeuse was in conjunction with the Sun. Before this event, its brightness was recorded at plus 0.4 magnitude. Observations using the stereo satellite in June and July 2020 revealed that the star had dimmed by 0.5% since its last ground-based observation. This unexpected change in April surprised many because the maximum and subsequent minimum were anticipated in August-September 2020 and around April 2021, respectively. Betelgeuse's brightness is known to fluctuate significantly, making predictions difficult. The fading suggested that a second dimming event might occur sooner than expected. The discovery of a second dust cloud, linked to Betelgeuse in June 2020, suggested that a cool patch on its photosphere might have been responsible. A separate study in August confirmed this hypothesis. Studies conducted in 2022 using the Hubble Space Telescope indicated that the dust cloud was created by a surface mass ejection. Millions of kilometers of material were ejected from the star's surface, where it cooled, compacted, and formed the dust cloud that caused Betelgeuse's fading. The shattered photosphere, several times as massive as our Moon, drifted into space, blocking the star's light from Earth's perspective. The fading, which began in late 2019 and lasted for several months, was visible even to backyard astronomers who noted Betelgeuse's brightness change. Even more remarkably, Betelgeuse's 400-day pulsation cycle, which astronomers have been tracking for around 200 years, has vanished. By studying Betelgeuse's surface motions and brightness variations, astronomers have developed a theory to explain the disruption. The star is slowly but surely regaining its brightness, and its photosphere is regenerating. However, its normal cycle has been thrown off, and its interior is now vibrating like a bell that has been struck. A massive stellar surface mass ejection of this scale has never before been observed. Something is happening with Betelgeuse that astronomers do not fully understand. We can immediately observe this new phenomenon and use Hubble to track surface details in real time. When will Betelgeuse go supernova? Probably not in our lifetimes, but in reality no one knows. Could happen tomorrow or in a million years. Will Earth be affected by the Betelgeuse supernova?
Well,
Betelgeuse's explosion will not harm life on Earth because it is too far away. Astronomers estimate that for a supernova to be dangerous to humans, it would need to be within 50 light-years. Betelgeuse is over 10 times further away than that. Instead, everyone on Earth will be treated to a breathtaking celestial event, a brilliant star shining in the night sky. When Betelgeuse finally explodes, astronomers will be able to study the star in its final moments. However, Betelgeuse is not currently visible in the night sky, so don't go looking for it. Even if it had already gone supernova, we wouldn't see it right now, except during the daytime in August. Betelgeuse is not only a key star in the Orion constellation but also plays a crucial role in our understanding of stellar evolution. Its immense size and unique characteristics make it an outstanding laboratory for studying the life cycles of massive stars. Observations suggest that Betelgeuse might undergo a substantial transformation, leading to a spectacular supernova event. This explosion is expected to leave behind either a neutron star or possibly a black hole, depending on the remaining mass after the explosion. Researchers are eager to gather more data on its behavior, particularly its mass loss rates and surface changes, which could provide insights into similar stars across the universe. Beyond its scientific significance, Betelgeuse has also captured public imagination. Cultural references, such as the 1988 film Betelgeuse, have helped solidify its place in popular culture. As it approaches the end of its life, public interest in Betelgeuse continues to grow, highlighting its importance both scientifically and artistically.